In this video, we will try to understand what exactly is the use of Columnstore index and in which scenarios we should be using it. Now, one of the questions which can come to your mind is, how is this Columnstore index different from a clustered and non-clustered indexes? In case you are new to clustered and non-clustered index, please go and watch the clustered and non-clustered index video on the Learn SQL Server section. So let us first try to understand that how is this index different from clustered and non-clustered indexes. Now we all know that in clustered and non-clustered indexes, we have an hierarchy of the root node, and then root node has an intermediate node, and then intermediate has a leaf node. And the leaf node actually points towards the data, and this data is stored into 8 KB pages. So we have a root node, we have intermediate nodes, and then we have leaf node, and the leaf node actually points towards the data which is stored in 8 KB page size, and it is stored in a row format. Now, what does this row format means? So you can see here that on my screen, I have a very simple table here called as TBL customer, and you can see that I have inserted a lot of dummy records into this, right? So now, and on this table also I have an index. So if you see this table structure out here, this table is having just 3 fields. There is an ID, there is a customer name, and there is a customer code. Okay. And on ID, there is a primary key, and that primary key has a clustered index. Okay. So this primary key out here has, this is a primary key, and you can see that it is clustered index. So now, so let me fetch top 10 star. Okay, so let me just order by ID. So you can see here, like I've just fetched the top 10 records. So we have the leaf node, and the leaf node is actually pointing to these records, and these records are stored in a row format in 8 KB pages. So must be, like on the first 5 records go into the first 5 8 KB page, then must be the second 5 records go into the second 8 KB page. So you can have multiple pages out there, and in each one of these pages you have these records fitted according to the size of your row. But now assume that you are fetching a lot of records. So you are fetching some columns from the first 8 KB page, you are fetching some column from the second 8 KB page, and so on. So if you are actually querying a lot of 8 KB pages, or if you are scanning a lot of 8 KB pages, that will increase your IO. So if we can go and rearrange this row type thing into a column type thing, then must be our IO can decrease. So if we can do something like this, we can fit one column into one 8 KB page. So for example, now we have from the first 8 KB page and from the second 8 KB page, we can take must be one column customer name and fit it into one page, right? Then we can have a second page in that we can fit the second column. So basically, Columnstore indexes is nothing but where rather than fitting a full row into one page, we try to just fit one column into one page. And by doing so, our input output will decrease. So now if I go and fire a query saying, okay, I just want customer name. Let us say I go and say, I just want to get customer name. So I don't have to scan lot of 8 KB pages. Must be I can just go and scan 1 or 2 8 KB page and get the whole column from that, right? So Columnstore indexes increases your select performance by fetching from less number of 8 KB pages, because the structure of storage is more column wise rather than row wise. Now because we are storing only one type of data, or I'll say one column into one page, we have a lot of scope for compression. For example, now let us say that you have records like this, like India, US, India, right? So what you can do is must be you can go and say, okay, all these Indias means one, right? So you can store somewhere in some other place India, and you can have a reference value 1 stored here, and with that the size of that record can decrease, and you can fit large number of records into one page, right? So again, there is a lot of scope of compression over here as well, and that's what Columnstore indexes does. First thing is it actually arranges the data in column wise per page, right? And second, it also applies compression, and by applying compression, you can store large number of rows in the same page, right? So and by storing large number of records in the same page, you don't have to again query large number of pages, right? Because you can just take the data from one or two page, because now it is already compressed and is fitting a lot of data into one page. But said and done, creation of column store indexes is definitely a very heavy process, because you have to go and arrange the data into the pages using the column structure. You have to go and compress and so on. So if your database is highly transactional, then column store indexes can be bad, because for the records inserted, it has to compress it has to align them into the pages, right? And that's a tedious work. But when it comes to selecting records, or when it comes to retrieving or reporting kind of scenario, then definitely column store indexes score on that, right? So if you have an OLAP system, OLAP, or I'll say analytical system, where the customer is more fetching the records, doing analysis, then definitely you should use column store indexes. But if you are having an OLTP system, where there is high transactions happening every minute, then column store indexes would go really bad on that. That's why column store indexes are meant especially for projects like SSAS, SSIS, and so on, where people build OLAP systems, right? So now let us go ahead and let us practically see that how we can how much is the benefit of column store indexes when it comes to retrieval. So now let us do something like this. Let us go and select customer name and customer code, right, from this TBL customer, and let us go and see the plan. Let us see that what kind of plan are we getting if we try to get all the records from the table. Remember, we have a lot of records on this table, right? So you can see that it is saying that the plan it is using at this moment is clustered index scan, and you can see that the estimated IO cost is something like 3.66. So you can see that I have moved my mouse on the clustered index scan operator, and it is telling me that the IO cost is 3.66. In order to see this, you have to go and hit over here. So you can see this display estimated execution plan. You have to click on it, and it actually tells you that how this SQL is going to execute, right? And in that, at this moment, the IO cost is the most important thing, because column store indexes, as per the funda, right, it should have less IO cost because it's going to fetch from less number of 8 KB pages, right? So now what I'm going to do is I'm going to go and create a column store index. So in order to create a column store index, here is the syntax. You have to say create non-clustered column store index with the name and on which columns you want to create the column store index. So now what he will do is, once you fire this query, it will take the records of customer code and try to fit it into the 8 KB pages, right? So for customer code, there will be separate 8 KB pages where only customer code will be stored, and for customer name, there will be separate 8 KB pages where only customer name will be stored, right? So let us go and execute this SQL, and let us actually go and see that if the column store index is getting created. So I'm going to go to the design mode here, and let me go and just check if the column store index has been created or not. So let me go to the design, and let me check indexes and keys, and I can see that the my column store has been created and the type is column store. You can see over here, right? So even you can create from the UI also if you wish. Okay, good. Now I'm going to go and copy this, and let us see the plan over here. So this plan is using the clustered index scan. Must be, we can remove the order by ID. We can just say clustered index scan. Oh, okay. Oh, that I just fired it. Actually, I was trying to keep two windows where we can compare, but that is fine. So if you remember, it was 3.66 something. Now, if I move my mouse here, you can see now the estimated IO cost has gone to 0.0031. So if you look at the numbers, they are, there's a vast difference, right? So basically, when you use column store indexes, the IO cost comes down and your select query becomes more better in terms of performance. So that's the syntax for column store indexes. I'm again putting it out there. The syntax is quite simple. So the way you were writing syntax for clustered and non-clustered, you have to write it exactly like that. The only thing you have to put here is the column store keyword. So for example, if you want to create a non-clustered index, this is the syntax, right? Create non-clustered index and then the columns. The only thing what you need to put is column store. That's it. And the column store indexes will get created. And also you can create columns to indexes by using the design mode, right? So in case you don't want to remember syntaxes, you can go and use the design mode. So let us quickly revise what we have learned. First thing, columns to indexes puts one column into one page, and because of that the IO decreases, because now you will be fetching from less number of pages as compared to the row kind of architecture, right? Second thing is columns to indexes also does compression. So by doing so, it tries to fit as many as records possible in one page, into less amount of pages. And the final thing is that columns to indexes is very good for OLAP type of system. If it is OLTP type of system, then you will have performance issues, because columns to indexes does a lot of background work like compressing, and aligning and those kind of things, right? So I hope that you enjoyed this video. In this video, we were trying to understand what is columns to index and how it differs from normal clustered and non-clustered index. Thank you very much.